It's the same as 6.375, which is the distance from the neutral axis to the outermost fiber of the top of the beam, minus 0.75, which is the distance from the top of this member to the center of this member, times the area, which is 10 inches, times 1.5 inches. And that comes out to be 84.375 inches cubed. Q for the bottom member, or the bottom flange rather, is 8.625 inches minus 0.75 inches. And this 8.625, as we said before, is from the neutral axis to the bottommost fiber, outer fiber, minus 0.75, which is half of the height of the member. So it basically goes from here to here, times the area, which is 6 inches, times 1.5 inches. And that comes out to be 70.875 inches cubed. Now we want to use our Q values for the top and bottom beams, or members I should say, to compute the shear flow Q. And that relationship is baby Q equals V times big Q divided by I, where this is the shear force. Times the Q that we just calculated, times the moment of inertia. And converting it from kips to pounds, it's actually 3,107 pounds times, and this Q is the Q for the top member, 84.375 inches cubed, divided by a moment of inertia, which is this guy. And that came out to be 219 pounds per inch. I'm just doing the same thing for the bottom. Except, of course, I'm using the Q for the bottom for this Q. So I'll just call this one QB and then QT. If you get my drift. And I calculated this to be 184 pounds per inch. Make some space up here. And then after doing all this, we can actually figure out what the spacing should be between each nail so that it doesn't come apart, based off the shear force that the beam is experiencing. And ultimately, this is really what we want to know, is how far apart should we, put our nails. That relationship is given by, we know that Q is the shear flow, and the units are force per unit length. So if we solve for the unit length, we get the spacing is equal to the force divided by Q. And they say that the force that each nail can resist is 500 pounds. So the spacing for the top beam is going to be 500 pounds divided by 219 pounds per inch. And we calculated that right here. So the pounds will cancel, and you're dividing by 1 over inches. Inches will go to the top, and you end up with 2.28 inches between each nail. The spacing for the bottom will be 500 pounds divided by 184 pounds per inch, and that will come out to 2.72 inches. Now this is the maximum spacing that you can have between each nail, so you can place them closer together, but you can't exceed the spacing. So I mean, ideally this will go to every 2 1/4 inches, and this will go to every 2 and 2 and every 5/8. I had to figure that out real quick. So every 2 and 5/8 inches. So that's my video. Hope it wasn't too bad. Hope you enjoy. Any questions, just leave a comment.